couple of
Yeah, that's right.
super. Yep. It's only a couple of months ago that I was up at the RSGB convention talking about Sporadic E, and there's been no new E's. Well, there's been one, which I'll tell you about at the end of this because I've dropped a couple of slides in. But fundamentally, this is.
Hang on. That's mate, don't worry about it. I'm just trying to get the cursor away from there, and it decided to stop on me.
Too much excitement for one evening. This is.
Yeah, I know. Yeah, definitely.
Just as a matter of interest for later on, folks, can you see my cursor moving around on the screen here?
Yeah.
Good.
Yeah.
Okay, thank you. Right, well, so what we're going to do is talk a bit about where we are, rather than do the full bolts and nuts and bolts on Sporadic E, because there really isn't the time for that tonight. But I just want to say something about where we are with what's been happening recently. So the idea is a quick recap on Sporadic E, what the main players are. Then we're going to talk about some of the more specific weather links. You can imagine, being a professional meteorologist, my link with Sporadic E is to do with the meteorological aspects of it rather than the ionosphere side of things. There are many experts in those fields who are better equipped than I to talk about that bit. But from what I've gleaned from papers and articles on it, there's a lot of connection between the two. So this quest of mine is really all about trying to find out whether those links between weather and Sporadic E are reasonable, whether they've got weaknesses, whether we can do something as amateurs to find out a bit more about them, and whether we can make more use of, say, the professional resources out there. At the beginning, I have to say a big thank you to my colleagues at WeatherQuest, in particular Dan Holly, who's done a lot of the programming work for PropQuest. This is propquest.co.uk, a website which is really useful for looking at Sporadic E as it happens in terms of the FOF2 and the FOEs and so on, but also experimental work on a new index, a predictive index for Sporadic E. So, quick recap first then, folks. This is kind of where I had to go right early on in my Sporadic E stuff. I started in the late 80s getting an interest because people, knowing I was a radio amateur and interested in, obviously, and a weather person, I was going to various shows, conventions and things, and people would come up and jab me in the chest and say, what's all this about thunderstorms and Sporadic E, and what's all this about so-and-so? And there's a lot of almost folklore. It's not quite folklore, but there's a lot of unsupported stuff out there about what causes E's and how it works. So from that point onwards, the late 80s, I decided I'd make it a little challenge of mine to try and get to the bottom of this and find out a bit more about what drives it and if there are any links that we can get a better feel for. So I want to draw your attention first of all to the bit at the bottom here, which is where I live. So it's the weather part of it, and there have been several elements where these features like mountain waves, jet streams, upper ridge patterns and thunderstorms have all been loosely and rather hesitantly connected with Sporadic E. The one problem, or the main problem we face with Sporadic E, is that if it's purely driven by solar terrestrial conditions, so the stuff up at the top here, there's no reason for it necessarily to be very tightly geographically focused, is there really? So the weather part is the bit which for me enables us to look more parochially at a local event and see if there's any links there. To get from about, well, between the surface and 10 kilometres above the ground, so 0 to 10 kilometres is the weather bit, say, in round figures. Sporadic E is up there at 110 kilometres. So we're a long way apart. And to pass through that, we maybe have to deal with seasonal stratospheric winds, which have a very marked change in pattern. If you look at it in a hemispheric sort of average sense over latitude bands, you can see that winters are renowned for strong westerly winds in the stratosphere, and in the summer you get very weak westerlies or even easterly flows. And the changeover from one to the other in the stratosphere, the bit in the middle here, does seem to fit in quite well with the Sporadic E season. So is it that? Well, it may be part of that. But then we get up to the ionospheric bit where the ease happens, and there are several things which probably are quite important. One, for example, might be the K index up here, because the geomagnetic field turns out to be quite important in how ease forms. The time of the day is possibly controlled in a large part by changes in the tidal winds in the ionosphere up there. So anything that's affected by the rotation of the Earth and the effect of the gravitational effects of the moon, or heating effects, differential heating effects from the sun, that can produce what is called a tidal response. And it may be in terms of temperature, it could be in terms of pressure, or it could be in terms of wind. And in fact, it's all three. But the point is, it does appear to play quite a big role in determining the time of day when ease tends to be more prevalent. And then we have the question about, well, what are ease? What is it made of? And it turns out, when they've launched rockets through Sporadic E layers, the content is very strongly dominated by metallic ions from the burning up of meteors as they come into the upper atmosphere. So there's a thing out there from way back in, I think papers first published on this back in the 50s, about something called the wind shear theory of Sporadic E. And just to cut a long story short, if you've got charged particles, ionized matter from, say, meteors as they burn up, these are present in the E region. They are present in the presence of the Earth's magnetic field. So the K index, you can imagine, might be useful for that. And they are also present in the terms of the background neutral winds up at those heights. So you've got charged particles moving through a magnetic field being blown by neutral winds. So the tides, semi-diurnal tidal winds, become important. The K index is important for the magnetic field, and the meteors are important for the charged particles because that's what produces the material. So if you have a charged particle moving one way in a magnetic field, it's going to be deflected. You know, the old right-hand thumb rule that we all struggled with in the physics classes at school. So if it goes in one direction, it'll be deflected downwards. If it goes in the other direction, it'll be deflected upwards. So you can envisage how you can collect this stuff from the meteors that are burnt up and converge it into a narrower, thinner layer. And that is basically the wind shear theory of Sporadic E. It's how the whole thing comes together. And for that, you need all these things to be in play. And that would explain why you could get, say, ease over a large area everywhere at certain times of the day. But why is Sporadic E localized? And the bit down here at the bottom of this schematic is where I think the local bit comes from. So let's have a little explore here. The KP index is the way we denominate the disturbed nature or otherwise of the Earth's magnetic field. So if you had a CME and it's messed up the Earth's magnetic field, that tends to give you a very disturbed KP index, which implies the Earth's magnetic field is all over the shop. So this business of moving our particles and deflecting them into a convergent thin layer may not work so well if the KP index is high, for example, because it doesn't know which way to go, because the KP index, the magnetic field, is all over the shop. So sometimes we forget how important that can be. I think it probably is fairly important in the grand scheme of things. And it often changes on quite short time scales. So the idea that we get a KP index as a daily forecast or something is probably not capturing the resolution sufficiently well to talk about it in the context of sporadic E. And what we need is much more fine-tuned measurements. And I've been looking at some data from a German website which logs all of the KP index data and so on, and getting a handle on that a bit better now. But if we take a look at some of the published articles on it and look at it on a climatological scale, by that I mean over seasons or over the course of a year, say, or many years. This one I thought was an interesting graph. The paper's referenced down here, but it shows that the KP index does have a background sort of bias depending on where we are in the solar cycle. So you tend to get lower values as you work your way through the solar minima, and higher values as we go up through a maxima. And sometimes you can get some very low solar maxima, and they tend to be following low KP index values. So there's one there, and so on. So that sometimes is a bit of a guide, but it shows, although these, you can, on the right hand side, the axis for KP index, where the letters KP are here, if you can't see this too clearly from how far away you're looking at it, KP equals 3 goes through the middle here. So there or thereabouts, KP is equal to 3. If it goes lower than that, it's a very good thing for sporadic E. If it goes higher than that, it's gradually becomes more limiting. And we can probably do a bit more with this. So I looked at this graph from a paper, which I thought, although it appears complicated at first sight, it actually is really rather a neat way of looking at the KP index and its likely effect on broader scale things like the season of sporadic E. So here's the scale from a KP index of +2, 3 minus, 3, and 3 plus. So it's a fairly short sort of scale, part of the scale, which KP, as you know, goes from 0 up to 9. So it's a logarithmic scale. But anyway, the months of the year go along the bottom here, along the x-axis. So in the blue region, which is low KP values, which, if you remember, are potentially good for sporadic E, you've got a good moment here in the winter, dead of winter, late December and early January. So some of you will be able to point to chance sporadic E opens out of season, in this midwinter period. And then we get increasing sporadic E in the equinoxes. So March, April, May, this area down here on the left, the early part of the year, the spring part of the year, quite a lot higher values up near the top end of the scale here. So these are showing that the equinoctial periods generally not meant to be too good for sporadic E. If you do get a bit of a let up, then it's at a minimum in the middle part of the day. So up on the y-axis here, we've got time of day from midnight at the bottom, 6 a.m. just before the text universal time, and about 15 to 1800 up here and 2400 up here. So in the equinoctial period, both autumn and spring, the lower values of KP statistically tend to favour the middle part of the day. So it might be reasonable or possible to expect to see a tendency to have sporadic E occurring around the middle part of the day at those times of the year. This is based on a very long data set from 1932 to 2019. So there's a goodly number of years there, 90 years of data. And then we come to the summer period where we've got these low values again. So you can see that the summer period should, in a KP sense, be supportive of ease. And the best period turns out to be the morning. Now, this is where it's a point perhaps for discussion, because we traditionally, don't we? We kind of feel that sporadic E, you have a blip sort of in the morning, you think, oh, that's interesting, it might really open up later. And then we all go on the bands in the evening, late afternoon, early evening, and that's when you get most of the openings. Now, it may well be that that's driven by a better population density of amateurs at that time of the day, people who've had the tip-off from earlier on, more activity, and so on. But from a KP index point of view, we should not be too surprised to see openings in the morning. So that's the KP index part of it. And we here now are just coming out of our doldrums period and heading into December, so we should start to see perhaps a stronger signature, who knows. So this next bit is a schematic of just to remind us how this whole thing comes together. So meteors drive the input, and here on the top left we've got a schematic meteor coming in, and they start to burn up. They don't just all burn up down here, they start from up here, and this meteor distribution of ionization is available from quite high altitudes, and the wind shear driven by these tidal winds in the E region. One of the parameters of a semi-diurnal tidal wind is that the nodes, what happens fundamentally is when the wind is influenced by semi-diurnal tides, it's a node that descends with time. And we're looking at the trend during a given period of a descending layer where the winds are favorable. It's this gravity wave type effect of producing it, that if you look vertically upwards in one place, the winds have a tendency to reverse, or at least the wind shear will favor this convergence of the material. So you start off at a higher level, and as the tide progresses, this useful interval of altitude descends with time. But at the same time as these tidal winds are doing the stuff, there's also modulation from below by what we call atmospheric gravity waves, these AGWs, generated by weather bits that are propagating up through that big gap of 100 kilometers of altitude to interact, like modulating your AM rig on top band in the old school days. It's interacting with these tidal descending nodes. So you get a situation whereby you have two periods where you've got this descending semi-diurnal tidal node during the day. You can see the time along the x-axis here. You've got one in the middle of the morning and one in the evening, where not only will the tides produce a favorable convergent sort of node, if you like, in the background winds, but also modulating that with the weather generated atmospheric gravity waves can produce a real localized peak. Now, this is important. This is the bit that actually makes sporadic E not happen on a regional European scale, but happens very locally where the weather gravity waves are operating most effectively. Now, sometimes they do operate in a wide scale sense, but mostly they give you very good regional focus on things. So because they're also, I've not told the whole truth here slightly, because there are semi-diurnal tides, which are the most significant ones in the middle part of the year, middle latitudes at this time of the year when we're looking for sporadic E. But there are other tidal wind periods interacting, because it's not just one unique mono frequency of tidal winds. There are many tidal wind phases that operate together and interact. So it's a real mess up there. and it just happens that the semi-diurnal tides are the strongest. But there are other intermediate periods which also can be significant, and then there's a diurnal one as well. So if you can imagine, these two semi-diurnal tides are feeding stuff in which gradually increases the amount of ionization in the lower E region. But we run into a problem, because as you get lower down, say below 100 kilometers, the profit and loss account doesn't look quite so good. So what you have is you have a gradual erosion of the E's from underneath, because you've got more air molecules. As the atmosphere gets denser as you go down, there's more likelihood of the ionization being quenched and the ionization recombining. So what tends to happen is that the E's can start off very strong up at the top here, and can be sort of very flighty and suddenly a big value and then not so big, and so on, because these tidal winds and the gravity waves and the weather bits, you imagine the turbulence that's going on, and how it has to be just right to make these convergent blobs, if you like. It's like trying to predict where the crest of a wave is at any one time, what it looks like, where the breaking foam is on the top of a wave, and things like that. It's all very hard to pin down, but the main point is there does appear to be a lower altitude at which you don't get much ease response, and that's because of this recombination thing. So if you look at a whole season, and I haven't got the data for the whole season for this year that we're currently in, there were several big chunks of it missing. So I've gone back and I've used the previous year, which was almost complete. There's a couple of gaps in here, but mostly it's complete. And these are measurement that now the top half of this double graph is a graph of the hourly maximum FOEs from a place called Doubs in Belgium for the period from the 1st of May to the 30th of September. So you've got virtually the whole of the nominal Sporadic E season in here. And the color of these vertical bars is suggested by the maximum value of this FOEs recorded by the ionosonde. And you can see that there's quite a few of them that reach a maximum value that exceeds the 4 meter threshold, and there's quite a number that exceed the 6 meter one. So in terms of the peak of the season, we're looking at sort of mid to late May through to end of August, first few days of September, and that, broadly speaking, is when we perceive the Sporadic E season to be. And the blue lines is the 10 meter openings, and then underneath is a graph where I'm experimenting with a predictive index to see what the weather parameters that I happen to be looking at suggest. And sometimes they correlate very well, sometimes they don't. But it's the differences are usually not to do with the yes or no part of the question, but they're to do with the maximum value of the E's as it's measured by the ionosonde, and how that relates to the EPI. Now, it's kind of a difficult thing, this, because remember at the beginning in our schematic we said it was all about the meteors coming in and providing the fuel for Sporadic E. So if you don't know how the fuel deliveries are going, it's very difficult to expect to get correctly predicted the highest value of FOEs that you're going to get, because you don't know how much fuel you've got to start with. So there's an element of picking the things that we can do something about and gradually filling in gaps for the bits that we don't know about yet. Now, the RSGB's Meteor project is coming along nicely. There's a lot of good work going on there. So I'm very excited about seeing some potential results from that, because what we would ideally like is some sort of real-time daily value of or hourly value of meteor input. That would be terrific. So so just looking at that season, when I was just looking at values above 10 meters, I've done another study since then where I've looked at all values, but looking at those that just reached 10 meters, 58% of the sporadic E reported by the ionosonde, 58% of them reached 10 meters. So that's quite a good season-wide performance, really. About a quarter of them only get into the LF lower HF bands. 11, say round figures, 10% get to 6 meters, and 5% get to 4 meters, and potentially 2 meters. It's a bit of a quirky thing to try and get these things to show a value that equates to 2 meters. So my correlation with a 2 meter opening is kind of limited by the fact the chances of getting a tiny ease patch that's strong enough to work for 2 meters over the top of an ionosonde is a big ask. But I think possibly we need to look at the thresholds that we're using for conversion. Anyway, point is the index, the predictive index, is always predicting more ease than not, and by and large that's a pretty good take. It looks like over a whole season the bias is to overestimate is to underestimate the ease at the beginning. In other words, underestimate the valuable ease. So what we get is a big swathe of stuff coming in from those less than 10 meters, and that affects things. But for those greater than 10 meters, 2.5 to 1 is the ratio between the occasions where I've predicted ease and not got ease. So the EPI is working, but the ratio improves as you go higher up, as you might expect. So between 50 and 75 EPI, we get a 4 to 1 ratio. There's fewer examples, so the numbers are smaller, but it's a 4 to 1 ratio, and then it tails off a bit at the higher values. So we're missing some of those. Anyway, it's work in progress, and I'm not quite sure we're looking at absolutely the right things yet. I've opened that up to be more a case of any value of ease, and that does change things slightly. So here we are with something that I looked at for this year. I don't know how many of you have used PropQuest before, if you've had a look at that, but the PropQuest graphs allow you on the tabs where you see the graph of the FOF2. You can also do one where you can look at the NVIS, which is just hives out the FOF2 and the FOEs, but there's also a climatological averaging one. And if you go in an average for a whole month, then you see some quite interesting differences. So for example, in April of this year, looking at, this isn't to do with what amateurs were on the bands at the time. This is purely from the ionosonde measurements of what the FOEs was. So for a whole month, this is time along the bottom, along the x-axis. So this is a whole day here, from midnight, midday, and midnight over here on the right, following day. So this is what the highest value of FOEs reaches. And looking over a whole month, you can see it's fairly sort of crackly and flitting about. There's lots of these different peaks in here. So it's very hard to pin down something that says, hey, wait a minute, you told us there was this double semi-diurnal tide that's going to be important. And the one thing about these tidal winds and anything up in the E region, let alone the upper bits of the weather part of the deal, it's very difficult to get measurements up there. So this is a very hard thing to pin down, but it does look as if the semi-diurnal tides aren't quite as dominant as they are in the summer when you look at this April early season thing. However, if you look at the other end of the season, and this is September, so quite recent, the message is don't give up just because you got out of the main season. So here we are in early September. We've got two FOE's measurements. So this is what the ionoson saw that got into 6 meters. And here's one that even just briefly blipped as high as 4 meters. And this is on the 19th of September, and another one for 6 meters. So the continuation of weak openings for 10 meters, sporadic E within Europe, say, must be something you're all familiar with, because we were talking, at the beginning that 10 meters has been quite good recently. And not just for openings to the States, but also within Europe. You suddenly get some very strong signals from all those sorts of locations within Europe, which are ideal for a first single hop sporadic E contact. And you can see, all these things sort of running through here right the way through the month, of reaching up as high as 10 meters, with the odd blip that goes even further. So what do we do about this one? Well, if we do the same thing for September, you've got the residual effect of our two semi-diurnal tides, where these orange arrows are at the top. They've picked out a slight tendency to higher values of FOEs in the morning period, and a tendency for a broader, possibly changing peak in the late afternoon, early evening. So that is kind of what's left of the high season diurnal twin peaks, so to speak. That'd be a good name for a TV series, wouldn't it? Right, so you've got those two normal semi-diurnal tidal things going on. And then you get sort of some very strange anomalous things. Now, I'm not quite sure what to make of this one, other than that it may be a single meteor type ping that's been captured directly above the ionoson. It's possible. I've got no way of explaining that. Otherwise, it's not necessarily a tidal effect, and it's a very thin single-hour response. So not single-hour, single being dubs. These are what are they? Every 10 minutes. Anyway, let's have a look at these a bit more closely. So 3rd of September and the 4th of September, you can see we've got a period towards the end of the afternoon in dusk period where you've got a brief blip, and you've got brief blips here as well. So the whole thing, I'm just going to move these pictures of everybody to the bottom, and you can see here there's another set of blips here. Now, doing this on a day-by-day basis, when you look at the FOF2 graphs, the one thing this could tell you, or if you look at these, if you see in the top left where we've got the tabs here, that NVIS one is a very good tab to press to separate out just the FOF2 and the FOEs, so you can see it more clearly. And something drops out of this as well, which I'm going to do a bit of work statistically on at some stage, is to look at the typical width of these pulses to see how long an E's blip will last if you get one at a given place. Sometimes you can get a broader zone, but for the maximum values, it tends to be fairly fleeting, a matter of 4 or 5 10-minute windows. You might be looking at something between 15 minutes and 45 minutes or so, and then it's past. And these are all good sort of working background rules to have. Why didn't that go? There we go. So if we look at the 3rd of September, now there's complicated stuff on here, so let me explain what we've got. The right-hand map is a chart of jet streams, and the jet stream strength is where the core yellow orangey color is, and that's deflected well away to the north of Britain. There's another low to the west of Portugal, and over the south of Britain and the near continent we've got an upper ridge. And upper ridges are one of those things which contains an element of turbulence about it on the ridge axis. But here on the left-hand upper left graph, the black line is the height of the sporadic E measurement. and the color coding is the highest frequency that we reach. So quite a lot of the time, 10 meters is getting an effect due to the value of the FOEs. And the height here is a bit random, but here you can pick up a fairly clear sort of descending note. And one thing that happens with the descending heights of E's is you tend to get a clustering of higher values of FOEs near the base of the descending node, which is what you might expect. And you just get a thin blip here, slightly olive green there for 6 meters. And then the lower left graph, these are a series of plots. So you got height on the y-axis, as you have on this upper chart. So this is the height of the FOEs, or the virtual height of the sporadic E layer. And the coloring of the dots is the time of day. So these purple ones up in here are the first bit of the afternoon. And then it comes through here to a grey colour, and this is early evening, late evening. So what happens is you get a big spread at low values of FOEs, because the graph axis, x-axis here is the FOEs frequency. So you get a lot of spread here. Nothing's together, it's all over the shop. And then it converges as it gets stronger. As the FOEs increases, and we get up to this sort of big number, then it's more or less settled at somewhere between 100 and 110 kilometers. Notice here as well, this orangey colored cluster of dots is representative of the morning tidal period. Excuse me. Morning tidal period, which does just about try hard to get something going and stops about here. So what can happen with these things is that the descending tidal node, if you like, is scooping up the E's, and then supposing the rate at which that goes is determined only by the rate at which the Earth rotates, which we can't do much about on a day-to-day basis. So that is going to go through there, and supposing it runs ahead of where the E's has got to, then you're no longer converging it together, and what's left, what's got as far as this intact, then gets eroded from underneath by the background winds and the recombination. So the thing can run away with itself. And then on the 4th, the next day, we had a similar thing, but this time we had a little bit more success with the morning period, and then we had another brief moment in the early evening that came up here. And again, it's at the end of a descending node. This one seemed to be a descending node, and then another one there didn't do anything, but all this clustering at low values. So at low values of FOEs, they're all over the shop. There's nothing really going to do anything for you, and you only see this converging like we're getting here with this morning opening, converging during that first tidal window, and then underneath it we sneak through in the purples in the afternoon to another one which does slightly better. And again, it's just on the edge of this upper ridge. So that was one example in September. So don't give up. The message here is don't give up the E season too early. I'm not going to spend a long while on this. This is just part of stuff. This is me and my other anorak with the weather bits of what might be producing the gravity waves that come up. But the middle graph I want to draw your attention to. This is this 3rd and 4th of September. So 3rd and 4th of September. First weekend in September, summer pattern, tend not to get too much unsettled stuff. The lower graph doesn't show any jet stream strength winds going on at all. So there's no jet stream influence here. The left-hand block of charts is the 3rd, the right-hand block of charts is the 4th. These top things are to do with vorticity and spin in the atmosphere and things like that, which I'm looking at. The middle one is the one I want to draw your attention to, because the red bars on the middle graph show you the FOEs, and here you can see a very strong response in the mid-evening. And it also, since I've latterly added the KP index into this, so the KP index we get a marked dip here, which comes just before that peak in the FOE's value. But when there's high values of KP, it's not quite so high in terms of the FOEs. It's not a direct relationship, because if you've already got E's and then it goes high, it takes a little while to degrade it, but it will degrade it eventually. Whereas on the 4th, the KP index was lower for a lot of the time, and as it started to fall away here, you got quite a high spike in the FOEs when it's at its lowest, rather than at these slightly higher values. But it's early days yet. It's going to have something to do with it, but the relationship is not necessarily just that, because if you've already got E's, strong E's, and suddenly you get a CME, a solar wind step up coming in, and everything gets distorted, you'll get a measurement of high KP value, but you've still got your already produced strong E's value. So it takes a little while for that to decay. And of course, that weekend provided plenty of examples of good paths. It was the 144 megs trophy type contest. So that's where I was at the weekend, playing with that. Right. So then we come to the 19th of September, which was the strongest one later in the month. So 19th of September on the edge of a jet stream. And here we can see that the earlier part of the semi-diurnal tide was weakish, but the afternoon part was much stronger and more a steeper slope, and you get these intensification of the FOE's values towards the end of the day. And the scale on this x-axis here with the colored dots is different to accommodate it. And this now shows that in the afternoon, you've got this increase that settles down just above 100 kilometers. And you can see the morning one was dramatically beaten by the afternoon one in terms of how far it reached. But it's a nice way of visualizing it, which I'm working on continuously to try and make it easier to see physically what's going on. So the plan is that these two will eventually join this one on the PropQuest website on a day-by-day basis. So you won't get the whole day, but you'll get how far we've got to on the day concerned. And that will be quite an interesting thing to see, because if you see yourself down in here and you're working DX on 6 or whatever, or 4 meters or even 2 meters, and you're down at the bottom here, then you know you've got limited time to go before the thing reaches the bottom and you start to get erosion from underneath from the recombination. 22nd, this is again another edge of a jet stream thing. You get a lot of shear on the edge of jet streams, rotation, vorticity in the atmosphere, and that can be a good trigger source. So here you can see a descending tidal node coming in, and here in the afternoon, evening period there is one, but it's not quite so strong looking. This one is a more sustained one and seems to do the job. So what we've got here are these colors, these purpley greens starting off early in the morning and slowly coming along here until we get to this single run that comes out just above 100 kilometers, and that's a morning opening. The purples, which is the afternoon opening, don't quite seem to do the job. They don't quite get there. There's a collection of them up here. It descends and you just get up to about 5 megs, whereas here you got up to 8 megs, which makes a big difference in terms of the band that opens up. And the corresponding pictures for those is a slight, looking again at the center graphs where the maximum FOE is here. You've got your peak in the morning, and you've got another peak in the afternoon, evening, late afternoon and evening. And this correlates with lower values of KP, higher values of KP in here, and it goes a bit quieter, higher values here and nothing much is happening. And then lowering KP can induce something if the other conditions are still there. And on this one, again, a drop in KP leads to a spike in the FOEs. So it's starting, I've only just put these on in a matter of a few weeks ago, just starting to experiment with this hourly resolution data on KP index, and it's potentially quite interesting. So looking at that, right, I spoke at the beginning about meteors being the input, and you have several meteor showers which should be considered as the fuel for sporadic E. But bear in mind, the random meteor input into the upper atmosphere is quite high too on occasions. So don't ignore the fact that there's stuff coming in all the while, loads and loads of it. So variations in that could supply some of the variability in sporadic E, for all we know. But certainly when you get big meteor showers, you can sometimes get some surprising enhancements. Like listening on 6 meters, you'll be hearing a station, and all of a sudden it's like there's a meteor burst coming through, and it's marginally an ease thing, not quite full on meteor burst, but it's almost like a hybrid effect. And that's why it's a good idea to have a calendar of the basic meteor showers pinned up in the shack somewhere. So this was the 6 meters AFS which I took part in, and here we've got the FOEs, and this is in October, towards the end of October, so not that long ago, and I worked an IS0 on 6 meters in the AFS. So, and that was a fleeting sort of isolated opening to Italy, which came about because of this relatively high, and actually for a contest, this was really good to see, a relatively high background FOEs value all the way through the period of the contest. I mean, it was uncanny. It was almost as if the RSGB had arranged it. I mean, it could be they did. Anyway, so that was really good. But it got me thinking how, and bear in mind we were talking about meteor showers before, and the 21st and 22nd of October is the peak of the Orionids. So here we are on the 22nd of October, and we get this out of season, sort of unusually strong, elongated period with good FOEs values. So I went back a year and looked at 2022, not quite so good that year. It only got up to 3.5, whereas the year before we were up at 5.2 megahertz here. So it's not quite so strong, but there is something there, and there was something in the evening on that year. And then here's another year, 20. What have we got here? What was that last one? 2022. Oh yeah, this is just the thing zoomed up. So this is 3.5 megs. So it's not as strong as the other one. And that then if you go to I think we've got hundreds of these things in here. This must be 2020. Here we go. Sorry, 2021. This one. Right. Sorry, I was looking at the date and thinking it was 22. This is 2021. Right. Let's just go back. Back we go. Here we go. This year, 2023. 22nd of October. Last year, 2022, 22nd of October, 3.5 megs. 2021, 5 megs. 2020, a broadish peak, but 4 megs or so. So here we are in October, where you're capable of seeing some activity up to perhaps 6 meters on a good day. Which correlates pretty well with the peak of the Orionids meteor shower. And if you do an average for the whole month of October this year, you get some quite interesting sort of peaky bits going on around the middle of the day. And casting your mind back to right at the beginning, where we looked at what the KP index does and how that tends to favor a middle of the day favorable period. Well, this seems to not pick up the dual peak of the day really very well, or if it does, it's shifted it. You've got this very late evening thing, which I think may well have been driven. I haven't looked into these dates of the high peaks, but I think these may have well been driven by the meteor shower itself rather than anything else. So here's the normal background ease bit, and that again got to be quite a high value. It got the highest value was over 7 megs. So it turns out that meteor showers can play a very big role in things, especially out of season. So just as a little bit of a guide, in the previous year, which was a more complete season of data for me, in May and June top right, July bottom left, August bottom right, I just want to draw your attention to the pie chart and the proportion of, so Noes is the browny color. In May, it's in the northeastern quadrant. Then we get the HFEs, which don't reach 10 meters. Blue is 10 meter E's, lime green is 6 meters, and the red is 4 meters. And June just explodes into activity for the higher values. And 10 meter E's remains more or less, on a rough perspective, about 50% of the time throughout this whole period. But it's these two 6 meter and 4 meter zones that really ramp up at the expense of the no E's at all. And still looks pretty good in July. And then in August, it kind of relaxes a little bit, but still worth doing. And those 4 months I thought were quite interesting. And then it occurred to me, looking at these probability tests of predictive element of the E's probabilities, you get a big factor of improvement the higher up you go to this middle value. So between 50 and 70, an E's probability index, I combine all of these things that you saw on the schematic early on and allocate a percentage probability for it based on the various parameters, some of which support E's, some of which negate it, and you come up with a single figure. Then it turns out that the ratio of success to failure for the figures that I'm calculating to be between 50 and 75%, it's a really big ratio. It's 28 to 1. It's 160 to 1 there. It's enormous. So the essence of why E's works based on the standard schematic is pretty good. It's just that you don't know on a given day which one is necessarily the more powerful. But something else to draw your thoughts to, I've only just put this slide together in the half an hour before we came down to West Sussex. And look at the shape of where the peaks are. Look at how the edges of the season peaks all favour the low values of EPI. And look at how the peak of the season ones all show a stronger performance for the higher values of EPI. So I've got some seasonal parameters in my E's probability index, and it appears that they work very well in the high season, but they overestimate in the lower season, which doesn't happen quite so often, and the lower ones I underestimate. So I've got some adjusting to do basically, and what I need to do is to revisit when I've got a bit more data how I calculate this EPI figure. Because wouldn't it be nice if you had a map, which we do on the PropQuest website, that would say where E's is more likely to be. So for next year, it's going to be a case of, I still think based on what we're seeing, look for jet streams. Look for upper ridges. These are just like highs on the surface map, but in the upper map, upper ridges produce turbulent cirrus cloud like this picture here. Look for those and look at these upper air charts that you'll see on the PropQuest website, because they'll give you a clue. And during the summer months, I write a specific text where I say what I think is the more likely excitement. The KP index is important and how it relates to stronger values of E's. Low KP index is a good thing. High KP index is not such a good thing. Meteor input turns out is going to be very significant, obviously, because it's what makes these. And you can get a lot of this data from looking at the ionosondes yourselves. Loads of places you can go to on the web to get these things. I'm just looking at the height of the E's layer, and I'm looking at the value of the FOEs. So it's definitely something you can tinker with yourself. Vorticity, the spin and turbulence in the atmosphere, is becoming quite an important thing. I'm going to add in some of the solar data. I'm going to try and get hold of some real-time meteor data. This plot of the map of the EPI, I'm going to continue working on. So the end result is that because of activity levels being reported on the clusters, and a big, thank you to all the people who submit their reports to all the various clusters. There's loads of them, but so long as you do that, then it keeps the activity levels up during an opening and gives many more occasions when you can explore what these parameters are doing and whether they're too high, low, need adjusting. And there's a few links which you can use to follow up, particularly the PropQuest one, and then others, bung me an email or whatever. And I think that is it. For those of you who haven't weakened and gone off for a cup of tea, now's your time. Or if you want to do questions, then feel free. Incidentally, I noticed the exotic call sign in our midst, and the map, the EPI index map, will cover the states, but there's no, at the moment, there's no data for ionosondes in the states. It's just how much I can store on our local server, which my company allows me to use. If I ask too much of the system, I think I'll eventually have to try and fund it myself, which will mean charging for the site. But it may well be we can get a token one for over in the States added to the list when I've developed some of the routines a bit better. Anyway, thanks for listening, gang, and hopefully that's been of interest and you'll be ready for next season.
Yes, thank you, Jim. Is there anybody with any questions? Speak now or forever hold your pieces. Doesn't sound like it from here, so
stunned into silence.
No, I mean, E's are always a wonderful thing to go and find. I mean, for someone who plays messing about down at top band and things like that, it's just so different just to go out and get these just wonderful magic bang open conditions. I mean, I run 6 meters from home. I don't run 4, but it's just brilliant just to sit and do it. I just sit there and look, load 6 meters, sit and work a load. But the thing I still get frustrated with the fact is now, yes, I know everyone's doing it and they're all using data and all the rest of it, but there's still the magic of sitting there working E's on CW.
Absolutely right. Yeah. And the interesting thing for me is where we go with predicting multi-hop E's paths, because we're all used to putting a screwdriver in the back of the set and hearing loud signals from Europe on single hop E's.
Yeah.
But when it comes to the multi-hop stuff, it's quite interesting how frequently these same parameters that determine where our regional E's might be in Europe, the same parameters you can see cropping up where multi-hop paths exist across the pond to the States or to the Caribbean. The only thing is, I did discover looking at it's not in this set of slides, but in a previous set or in an article I did once, I dug out some data for the climatology of the mean winds in different months of the year across the Northern Hemisphere. And it turns out there's a very particular shift in the pattern of jet stream behavior at the other end, at the Caribbean end of these multi-hop paths to the Caribbean, such that by the time you get into the peak of the season, the path openings to the Caribbean and the southern part of the Atlantic route are less favorable because you lose the last hop, if you see what I mean.
Yeah.
The climatology of the jet stream doesn't exist very strongly at all once you get into high summer. but it does early in the season. And I haven't looked into it yet, but it wouldn't surprise me if we found that there were different phases of 6 meter transatlantic DX that supported paths to the northern states or the northeastern states at one time of the year, and to the Caribbean at another time of the year within the East season.
Yeah. I mean, we're lucky in that respect that there are so many stations in the northeast USA that are possible contacts.
Yeah.
I mean, for knowing people over there when they're looking for the north-south stuff, of course, for them, that's their only opportunities sometimes to work some countries easily when you get the openings. But, they speak to us and they say, well, how many countries have you worked? Oh, loads of them. But then, we got tons of countries to work in.
Well, I agree entirely. That's an amazing point. If you add up what's available in Europe, it's well over 100, isn't it?
Yeah.
But for the American side, you'd presumably have to go to all over the Caribbean and the north of South America, right. I guess.
Yeah, and you say, well, how many countries you worked on too then? I said, well, if I just go portable on the hilltop in the summer, I can just sit and bang off countries just one after the other. Oh, you can't do that,
but even for the, if the season is good, and these conditions that I've been talking about tonight, if these are in lockstep, and bear in mind, once you're dealing with transatlantic paths, you've got to have 3 separate ones that are all good. So that usually means individually the weather bit early in the season is disturbed enough with lots of jet streams to make it possible to get that. But you've got to have the big sort of global hemispheric scale ionospheric things working in your favor as well. And when you think you've got losses with each hop, whereas in Europe you get these 5 and 9 plus goodness knows how many, because you've only just got one low loss refraction from the ease region. So it's a really fun thing to get involved in, isn't it?
Oh yeah, I mean VHF is just, well, I call VHF anything from once we get into 6 or 4 meters and what happens there. Well, it's like hearing the broadcast stations and things like that, isn't it? Same thing. TV channels on 4 meters.
Yeah, absolutely. I must say, when you look at the EPI map in the States, when the States has an opening, you see, the thing is, people say, well, why is it, and perhaps we'll get some comment on that, why is it when you get good ease openings in Europe, the American side doesn't seem to do very well with its openings, and vice versa?
That's right.
And it is simply because there are different weather systems involved. The weather systems at either end, even notwithstanding transatlantic paths, but within Europe or within the States, there will be different weather. There's no rule that says we have the same type of weather system at the same time the States does. But I was going to say, but when you look at the EPI maps, when you do get a good opening in the States, it does tie in really well with those hotspots of the EPI index, and so it looks like the same physics is working. Mountains play an important role in this. So we've got the Pyrenees and the Alps, and we've got the Ardennes, we've got the Harz Mountains, and we've got the Pennines. We've got all these things which can be very good at generating these gravity waves to determine the geography of ease.
Yeah, but the other thing is, of course, it's just like the whole weather pattern of a very large 3,000 mile plus continental landmass is completely different to what we get here on the edge of an ocean.
Yeah, totally. Yeah. Do you work ease over there in the States much yourself? I can't.
Where's Bob? There he is. Yeah. Hang on, Bob's. Come on, there he is.
One of the problems that I have, I'm in an antenna restricted area now. Before I moved here 7 years ago, I did.
Right. Okay.
Now all I have is a magnetic loop.
Oh,
and
right.
It's surprising though. I can work most of Europe most of the time on that magnetic loop.
Excellent. What band is that? 17. I heard you mentioning earlier. That's.
I used to do a lot on 20.
Uh-huh.
But in this cycle, I've moved around a little bit more, and usually, of course, uh, 40 isn't very good for me during the day. I lose
Right.
40
Yeah,
very
yeah,
early in
no,
the
quite.
morning. So most of the operations that I'm doing is 17 is very good.
Yeah,
17
good.
is one of my favorite bands. Of course, uh, when I get aboard ship, that's when I get excited because that's when I can work a lot more and hear a lot more.
Ah, right. Okay. Yeah.
Yeah, but there, of course, I have an excellent ground plane. And the antennas that I use are 60 feet above the water.
Oh, wow.
And uh, so on the weekends, on Saturday morning, I used to work all day Saturdays, but my age and health are catching up with me. So now I go aboard ship most Saturdays for around 3 to 4 hours, and I really enjoy myself.
Excellent. When you say aboard ship, Robert, what ship is that, Bob? What were you?
The battleship New Jersey.
Oh, right. Yes, I've seen pictures of that on the web. Yeah,
Yeah,
excellent. Excellent.
yeah.
Good.
November Juliet 2, Bravo, Bravo.
I'll listen
And
out for you.
normally, if you listen in CW, the best way to find me, I've told people, is look at reverse beacon,
Yeah.
Yes, yes, of course. Yeah. Yeah.
and that way you'll find out about where I am. Now I'll move around. Uh,
Yeah.
like tomorrow morning, like I say, I'll start out on 20 meters on 14052, but I know that with all the contests going on this weekend, I'm going to end up on the work bands.
Yeah, yeah, no, me
Yeah,
too. I,
yeah.
I'm nearly all CW operating wise, and I love QRP on 40. I do a lot of work on there, and yeah, it's very satisfying. Incidentally, about compromised antennas, the only time I happened to be in the shack when there was one of these transatlantic openings to the States on 6, I was working about half a dozen stations over there, just using my 80-meter wire doublet.
Yeah.
It's amazing what you can do, if you're in the right place at the right time. But otherwise, you do need something a bit more specialized, I guess.
I just purchased an ICOM 705, and
Lovely.
I can't believe that transceiver is one of the best transceivers that I've ever used. I have a Collins R390 just below me, and
Uh-huh.
I always thought that was a good receiver.
Yeah, yeah.
It doesn't compare. Now, of course, I realize that needs filters at this point, but still, it doesn't compare with this IC 705 QRP on a magnetic loop.
No, that's interesting. I've heard several people comment favorably on the 705. I'll tell you the other one that's nice if you're into QRPs, and that's the QCX kits.
Yes.
Yes.
They're really, really
Superb.
nice. Very good.
Yeah.
Anyway, it's really nice talking to you, Bob, and let's hope we can do one of these at transatlantic things with you on the battleship.
Hey, that would be great. That would be great. I do more stuff into the UK than anywhere though, because I have friends all over the UK.
Good, excellent. Well, I'm sure the path is very good at this time of the year for that. No,
Yeah,
that's
yeah,
brilliant.
yeah.
Excellent. Good. Well, it's nice meeting you all, and the
Yep.
cups of tea going down well in the club room, I see.
Yeah, we're having marrying a listen, having tea and cake. So
Oh, cakes, yeah. Oh, dang.
You
Well,
still
they
haven't
look,
figured how to send that over the wire though, have you?
they look very nice. Oh, Stella, that's fantastic. Thank you for the offer.
Put one in the mail. Trouble is, but the snail mail, it'll come up there a bit stale.
Yeah, I've got a feeling it won't survive. I'll just have to go and get a cookie out the pot in the kitchen and
Right.
locally.
Yeah.
Where are you located in the UK, Jim?
I'm near the city of Norwich in eastern England.
In Eastern?
So about 120 miles northeast of London.
Yeah,
Um,
yeah, that'd even be north of Bletchley.
Oh yeah,
Yeah, a
northeast
little
of
bit.
Bletchley by
Yeah.
quite a long way.
Yeah, yeah.
It's the rounded shaped piece that sticks out on the right.
Uh-huh. Yeah, of course I have a friend that used to it still belongs to mid Sussex, but years ago moved up to Mablethorpe.
Oh
And
yes, yes.
yeah, so I used to belong to that club, the Eagle Radio group, but they've more or less disbanded recently.
Another-
But I still belong to Denby Dale.
Oh,
And I
yes, yes, I've spoken to them a while back.
yeah, yeah.
They're a very big club. I belong to the Norfolk Radio Club here.
And
We're very,
yeah.
very big and keen on our CW contests and
Yes, yes. Yeah, as a matter of fact, I think that the Norfolk Club also teaches CW, don't you?
yeah, I'm one of the instructors. Yeah,
Yeah.
yeah. We're very big on our CW. We find people now getting huddles and run away when they see us walking into the room.
Good for you.
Mm.
It's surprising. I guess it was around the year 2000 when the CW population changed. Well, I noticed more recently, more and more people are getting interested in CW again.
It
You know,
is
I
good
know.
to see, isn't it? Yeah. Well,
Yeah.
well, we find that the ones that we've got a membership of about 240 people in the club, and of that 240, we've got maybe 30 of them who are good enough users of CW to be in contest groups with us and field. Some year in the past, we've had four field day stations.
Wow.
We struggle to get only one now. As we've all, as you say, Bob, as you get older, you don't have the energetic folk to sustain it. But CW is definitely popular, and these little QRP rigs, I think the 705 is going to encourage a lot of people on. I use a QCX. I use a Flex as my main rig, but my portable rig is quite often a QCX kit, which I love on 20 meters. And I think there's a new multi-band one out there, which I'm probably going to have to get at some stage.
I
I
believe you're
just love
right.
it.
Yeah.
Just love, and also the other thing is our folk, we are getting more into trying to teach them the notion of conversational CW.
Yes.
Yeah,
Uh, so,
Yeah.
that is
it's not.
hard because it's really. I mean, if you listen to the bands, it's it is only a report and that's it. And
Yeah.
heaven forbid you ask someone their name or even give your own name. You know.
It's tragic, isn't it? And so
Yeah.
we get them all to think outside the box when it comes to practice pieces and things like that. So hopefully we're going to get a bunch of people who'll quite happily have the conversational QSOs, which is I mean it's one of those things that's so much fun. You just wish other people would be able to get it and enjoy it, and yet when you do talk to people who just don't see it and don't want to do it, there's no way you can persuade them how
I
much
know.
fun it is.
I know. But
Anyway,
it is. I mean, we say Bob's saying about the 705. Yeah, I've got a 705, but you take that out, even on its own battery with 5 watts, which
Yes.
yeah,
it's a great little CW, and you can work anything on it.
yeah, absolutely. Over the years, I've spent a lot of time just using wire antennas. I've got a hex beam now, which I've got the 40-meter elements added on, which is brilliant. It's such a fantastic antenna. But before I got that, I'd been running with QRP here, and I've got over 100 countries on 5 watts
Yeah.
CW on 40 meters, on 40 meters.
Which, perfectly doable.
Yeah, for a small garden, it's
Yeah.
only about 50 feet at the back and 30 at the front. But
I've got the same sort of thing, but I've put up antennas to work both ways. So I've got like a low on 40, a low end-fed half wave on 40, which is great in the UK and Europe. But then I've got phase verticals on 40 for the long distance stuff.
Wow.
So that gives me both, and I've the same thing. I've got vertical on 80, but an inverted L as well. So
what do you use on top band, Phil? You mentioned top band earlier.
Inverted L with a trap with inverted L, 40-foot tower, goes upside the tower, goes out from that, trap on 80 meters and continues for 160. And it's resonant on 35, 40 and 1830.
Okay. Yeah, good.
Yeah.
No, I can't. That's the one band I can't really do much with, top band.
Yeah, I mean, no, I've got a few nice cards on 160.
No, well, it sounds like you do very well with it. It's excellent.
It's not big, but I'm in the Ada River Valley here, you see, so the grounding is exceptionally good. But I've worked stuff that way beyond what should be possible. When you get cards on the wall with Clipperton Island, you know, for 160, you think, yeah, it's not bad.
Oh, very tasty.
Yeah. So,
No,
but
that's really good.
yeah, but
Really.
the weekend I'll work. I mean, the major contest stations all down near Bob, all down the East Coast USA. I mean, they're all easily workable on 160. I can work them on 10. I can work 160 on 10 watts easily.
Excellent. It's all in. Yeah, the antenna's just so important, isn't it?
Yeah, but
Goodness.
but the other thing is I've got a Wellbrook loop I use as well for receive. So
Right.
and that's rotatable. So
Okay.
yeah.
I because of the really high noise, I've got an S6 noise level here, and it's constant on 80, which makes it difficult. So I put out a ground loop around the back garden,
Yeah.
and that's very effective at reducing some of it. And it's amazing what you can hear on a ground loop.
Oh yes.
I was copying an Oscar Alpha Peru on 80 meters on it.
Yeah.
Quite easily. So it's incredible, this notion that you have to have something fantastic in order to get a signal.
No, I mean, yeah, I mean, 80 meters on, you know, is a good one, but I use the what's it, aeronautical beacon on 80 meters.
Oh yeah,
The transmission, the one on 3485.
I know.
Yeah, 3485 upper sideband.
Yeah,
I use that as a reference point because I can listen to that, then I know what 80 is going to be like.
Yeah, no, that's a good call. Yeah.
Because
Is
it's
that,
just there.
not
It's
that
always
is
there.
that Gander or
Yeah, Gander Volmet.
Gander Volmet?
Yeah.
Yeah, good stuff.
Yeah.
Well, this has been most excellent chatting to you, folk, and really nice to see you all.
Okay,
Our
great.
local club has a contest net on a Friday evening on 2 meters, which starts at 9 o'clock. So I think I've just heard them. Yeah, I've just heard them open up on that. So,
Do you still have meetings? Do you?
well, we do. We have one a month, sometimes two if we're lucky. But to be honest, it's quite hard getting people to come to them compared to before the COVID. One of our guys is a big software engineer and used to worked in the television studios locally, and a very good engineer. And he's started a Raspberry Pi group, which I belong to. So we go and do a lot of coding, which suits me for the propagation stuff, but also designing logbooks and just getting into that a bit. So that's
now. Yeah.
So how about you? You're once a fortnight in person.
Twice a month it is, Jim. It's second Friday. It used to be every week, but since lockdown, it's been reduced to that. But we have the same problem. Although we don't have as many members as we do up there, we still, I think all the clubs have got the same problem about getting members physically back to the club.
I mean, I think one of the things it would be true to say here is that you know, when it comes to talks like this thing we've just had, sometimes when you do those online and you can look at the screen locally at home big enough to see what the slides are showing, it is a slightly easier experience than being in a room and looking at it behind 20 rows of seats.
Yeah.
You miss the personal touch, but you've got slightly preferential sort of deal on the slides. But otherwise, the meetings in person, I think, are good. And of course, there's cake.
Oh yes, that's one of the things. We're running you on a projector so that people around.
You can also look up what you're doing while you're talking about it.
No, that is very true. That is very true.
Yeah.
Hey, well, I'm gonna love you and leave you and say thank you very much for the invitation.
That's all right. Lovely to speak to you.
And you folks have a great Christmas season down there or across the pond, and look forward to catching up with you on the bands at some time, even on Sporadic E. You never know.
Yeah, never know.
Thank you very much.
Right, thank you.
You're very, very welcome.
Bye then.
Cheers. Bye.
Cheers.
Right, that's that.